Okay, today we're looking at this polynomial here. Alright, I want to try and find all of its zeros. In other words, where does this thing cross the x-axis? Okay, couple of things that I want to know are how many times it could cross the x-axis. 4. In other words, I'm going to get 4 answers. If those 4 answers all happen to be real numbers, that means that this thing, this graph, when I graph it, will actually cross the x-axis in all 4 of those places. Okay? However, sometimes I get an imaginary answer. But do I ever get an imaginary answer by itself? No. If you think back to any of the ones that we've gotten, even on this sheet that we just did, any of our answers that had imaginary numbers, if you don't mind, I'm just going to pull this one up for a second. Take a look at this one from number 6. See, I had one real number, and then I had these two that came as a pair. Right? So your complex answers, your roots here that have imaginary numbers in them, will always come as a pair. Always, always, always. Okay? So that kind of ties into, all right, if I have, the degree here is 4, right? So how many total answers am I going to have? There's going to be 4 in total. So how this could kind of land is that I could have 4 rational answers, or if I'm going to have an imaginary answer, it's never going to appear by itself. It's going to appear in a pair. So what I could also have is 2 rational answers and 2 imaginary. Or what else could happen? I could have all 4 be imaginary. That's really my 3 different options. Okay? So either I'm still going to have 4 answers however they land, but either 4 are going to be rational, or it's going to be 2 and 2, or all 4 will be imaginary. Because imaginary numbers will never come as singles. They always come in a pair, because you always have that plus minus root. Okay, so I know I'm looking for 4 answers at the end of the day. I have no skills right now as to how to find those 4. Or do you? I don't know. What could you do? If I didn't tell you anything and I said, you have to find,
Synthetic.
What would you do with it though?
Synthetic substitution.
What would you could, and what would you plug in? Well, if you plug in 0, that would get you your y-intercept, but it's not going to get you your x-intercept. You're on the right track, though. We are going to do synthetic substitution, but how do we know what numbers to plug in?
152.
No, good guess, though. There is something called the rational root theorem. You ready for this? Rational root theorem. And here's what it says. Any of the rational roots that are going to work, if there's any that are going to work in this, it's going to come from this list of numbers. It's going to come from the factors of my constant divided by the factors of my leading coefficient. Okay? So, any rational roots that exist will be contained in the list of factors of constant divided by factors of leading coefficient. And for all of these, we're going to take the positive and negative roots. Or factors, sorry. Oh. Good morning, Miss Sabia. Hi. Yes. Sure. No problem. Bye. Alyssa, see Miss Joseph in the cafeteria when you go down to lunch. Okay. All right. Miss Sabia, I'm already lost. What are you talking about? All right, let's break it down. What is the constant in this crazy polynomial that I have? 24. Okay? You don't have to worry about the sign because we're going to take positive, negative of all of them. So here's what I like to do. I like to list all the factors of 24. So here's the factors of my constant, which in this case is 24. Okay, so what are the factors of 24? In other words, what numbers divide into 24 evenly? 1, 2, 3, 4, 6, 8, 12, 24. Right, that's all of them? Okay. Then you're going to take the factors of your leading coefficient. What's my leading coefficient? In this case, it's just 1. Okay, so we got off easy this time. But let's say it were 6, then I'd have 1, 2, 3, and 6. In this case, it's 1, so the only factors of 1 are 1. So now the list of possible rational roots comes from all of these numbers divided by all of these numbers. I know there's only one of them, but if there were more than just one, I'd have all these factors divided by all of these factors. So in this case, it's going to be, so let's write this. So list of possible rational roots. So it's going to be positive and negative, all of these numbers divided by all of these numbers. Again, since there's just the one, it just ends up being that list, positive, negative, all of them. I know this seems like a big list, but you just went from infinity down to this many numbers. So, in other words, if this thing crosses the x-axis, it's going to happen at one of these places. Well, I take that back. If it crosses at a rational location, it's going to be one of these. It can be 4, but I could get just 2 of them and then 2 be imaginary. But we'll get there. So, now here's the semi-tedious part. We are now going to use synthetic substitution, and you basically just have to go down the line until someone gives you a remainder of 0. There's,
I don't like it.
it's, you come to like it.
Still don't like it.
I don't like math.
Oh. So, let's start ourselves off. So if I go back to the original, right, I'm going to drop down all my coefficients. Do I need any 0 placeholders? If this is my original, do I need any 0 placeholders? No, I don't. So let's drop down those coefficients. 1, 5, 2, negative 20, negative 24. So basically what I need to do is I need to plug in these numbers, and it doesn't matter what order you're going, you're just trying to find the first one that works. So I'm going to plug in 1, and I'm going to see if 1 gets me a remainder of 0. As soon as I realize a number is not going to give me a remainder of 0, I stop. Yeah, see, I'm not even going to finish because I know it's not going to,
Every number?
until I find one that works. I know. Usually, it won't take you that long to find the first number that works. We hope.
Yeah, what is it?
So, 1 did not work. Let's try negative 1. Nope. Okay, negative. So, I'm going to cross those out. Let's try 2. You can either erase, you could write your numbers again, but let's try 2. Let's see what happens with 2. I have a good feeling about 2. I want 0 as a remainder. By golly! Yay! You found one of the 4 answers now. 2 is an answer. 2 is one of the zeros of that crazy polynomial. Cool. Kind of, yeah. Now, remember what these numbers are, though. Do you remember what they are? These are the coefficients of what's left over. So what I have basically done is I've taken this crazy big thing in the beginning, and I have now factored it a little bit. I now know that x minus 2 is a factor, right? So now I have taken, I don't know if it's, and the bell's going to ring, oh my gosh. Here's my crazy original, plus 5x to the third plus 2x squared minus 20x minus 24. And I have split this up now into x minus 2. And then remember, these are all the coefficients of what's left over. That's my remainder. That's my constant. X to the first, x squared, x to the third. And we'll finish after lunch.
I should have read that.
Yeah, we're still here.